Hello students. In this video, I'll be introducing you to the unit What's in My Cupboard. So what's this unit about? In this unit, we'll be focusing on the broad topic of acids, bases, and salts. And we'll try to understand the macroscopic properties of a system in terms of what's happening on the ionic, molecular, and atomic scale. So let's get started. On your screen now, you can clearly observe two different images of Rio Tinto River, which is located in the Andalusia region of Spain. I want you to pause this video and write down two observations that you can make and two questions which come to your mind upon seeing these images. Once you have written down your observations and questions, you can resume the video. Now, before answering those questions that you may have upon seeing those images, let's try to understand more about how molecules and ions behave when they come in contact with water. So let's start with a very familiar example of sodium chloride. We all know that sodium chloride, that is common salt, is made up of a positive sodium ion and a negative chloride ion. And these sodium and chloride ion are held together by strong electrostatic forces. And because these forces are too strong, that's the reason why sodium chloride exists as a solid. But does it always exist as a solid? The answer is no. If you add sodium chloride in water and if you stir the water a little, you observe that the sodium chloride dissolves. So, what is actually happening on the molecular scale? On the molecular scale, the water molecules are playing a game of tug of war with the sodium and chloride ions. Basically, the water molecules are polar. That means they have a certain charge on themselves. So when the sodium chloride unit is surrounded by water molecules, these water molecules start pulling the sodium and chloride ion apart. And after some time, these forces of attraction between the water molecules and the ions are able to overcome the electrostatic force that exists between the sodium and chloride ion. As a result, you are able to obtain the ions independently from each other. This process of separation of ions or formation of ions is called ionization. So, ionization is the fundamental idea on the basis of which acids, bases, and salts are classified. So, what is ionization again? Ionization is the process of formation of ions, be it positive ions or negative ions. As you can see, different substances ionize in water in different ways. You can see here four different examples. Now you might see some sort of a pattern here. In some cases, you have an H plus ion as one of the products. In other cases, you have a OH minus or more than one OH minus as one of the products. And in some cases, you neither have an H plus nor an OH minus. You will see later that it's the way substances ionize that allow us to classify them as acids, bases, or salts. So, what are acids? In the context of ionization, any compound which ionizes or dissociates in water and releases H plus ion is called an acid. As you can see in this image on the right, hydrogen chloride is in fact a gas. But when the hydrogen chloride comes in contact with water, it splits into H plus and Cl minus ions. This process of dissociation or ionization and making H plus ions in water is what allows us to consider HCl as an acid. Let's take another example. One of the strongest acids which we commonly use is sulfuric acid. We can see what is happening to sulfuric acid in water. So sulfuric acid also undergoes ionization, that's means splitting into ions in water. We can see that it splits into H plus ion, two H of plus ions, and a sulfate ion. Notice that the sum of the charges are such that they neutralize each other. But based on our definition, sulfuric acid can also be considered as an acid simply because it releases H plus ions in water. Now, in many texts, you will see the term H3O plus appearing as well. So, what is actually H3O plus? Basically, H plus ions are too small to exist on their own. Just imagine what are H plus ions technically. You have a hydrogen atom which has a nucleus and an electron. Now, if you remove the electron, you are just left with the nucleus which has just one proton, and that essentially is what an H plus ion is. So you can understand that H plus ion is just too small. Because it's too small, it usually doesn't exist independently. And the electrons on water molecules are attracted to these H plus ions. And hence, in the process, this H plus ion binds to the water molecule. And together, they make H3O plus, that's called a hydronium ion. So, some definitions use this idea to say that acids are substances which release hydronium ion, but do understand that hydronium ion is just nothing but a single H plus ion that is flanked by a water molecule. Both the definitions are correct. So does that mean that all compounds which contain hydrogen atoms are acidic? So would that be substances like methane, which is a part of natural gas, which also has carbon? Would it make it acidic? And the answer is no. So why are some hydrogen containing compounds acidic while others are not? Basically, for any substance which contain hydrogen to be acidic, the bond should be so weak that it can be broken down by the water molecules, as we saw in the example earlier. Now, one general criteria that you can use in order to identify which substances containing hydrogen can be considered an acid is this simple rule. If the hydrogen is directly bonded to a group 6 or group 7 element, then you can consider that as an acid. You saw earlier that in case of hydrogen chloride, hydrogen was directly bonded to chlorine, which is a group 7 element. That makes the bond relatively weak, and that allows ionization to happen, causing the splitting to produce H plus ion. Now, on your slide, you can see images of two molecules. I would like you to pause the video and try to identify on your own which of these is going to behave as an acid. Alright, so the structure on the left is phosphoric acid. But the thing that makes phosphoric acid an acid is the fact that we have three hydrogens which are directly bonded to the oxygens. And as I said earlier, if a hydrogen atom is directly bonded to a group 6 element, it normally makes the bond weak. and this causes these hydrogens to become ionizable. That's why in the previous slide you saw H3PO4 ionizing to release 3H plus ions and PO4 3 minus. Now the image on the right is methane, which is natural gas. Notice that carbon is a group 4 element. The bond here is so strong that it cannot possibly be broken by water molecules. Hence, methane is not considered as an acidic substance. To be honest, in an exam, you will never be asked to evaluate whether a substance is acidic or not based on its structure. Rather, questions are usually based on the properties, which will be covered in later videos. Now, acids are not just restricted to laboratories as the image that you can see over here, rather, they are all around us. You know that all living entities are made up of genetic material, which is primarily DNA, which stands for deoxyribonucleic acid. You know, citrus fruits such as oranges contain citric acid. You know, carbonated beverages contain carbonic acid. You know that bee stings because they contain an acid called formic acid, which is also found in the sting of red ants. Substances such as malt contain some organic acids like pyruvic acid and malic acid. The nettle leaves also sting because they contain an acid which is called formic acid, the same that's present in the bee sting. And lastly, even some medicinal drugs such as aspirin are acids. The technical name of aspirin is acetyl salicylic acid. So we see that acids are all around us and some of them are really, really important. Now, coming back to the context of the Rio Tinto River, the Rio Tinto River is red, but its color varies from region to region, and that is primarily because of different concentrations of iron in water. This river is also known to be very acidic. Now, I would like you to pause this video and instead start viewing another video which is based on Rio Tinto before returning back to this video. The idea is that you get a basic understanding of the composition of the Rio Tinto River that would probably explain some of the observations you made and some of the questions you had. So return back to this video when you have watched the video which is linked in the discussions tab. So, before moving further, we need to discuss the key concept that we need to address in this particular unit, and that is the key concept of change. Now, in context of the IB, change involves conversion or shift or movement from one state to another. But in the specific case of sciences, we see change as a difference in system's state when we observe it at different times or at different places. In the context of this unit, the system that we have is the Rio Tinto River. Changes that you can see in a system such as Rio Tinto can be qualitative or it can be quantitative. Changes can also be irreversible, reversible, or self-perpetuating. Now, based on the video that you watched earlier and the basic understanding of ionization and acids, I want you to answer the following questions in your notebook. Once you have answered the questions in your notebook, please show it to me so that I can make sure that you have addressed the question fully. Once you have shown me the answer, you can continue watching this video. So I'd like to end this video with the statement of inquiry for this particular unit. I would not like to read this, but I would like you to pause this video and read the statement of inquiry on your own. Once you have read the statement of inquiry, I want you to list what is the key concept, which perhaps you already have an idea about, the related concepts, and the global context that are a part of the statement of inquiry. And I want you to write an initial reflection on how this statement of inquiry could be related to the context of Rio Tinto. Thanks for watching this video. I hope that you understand the context of the unit and try to make sincere efforts in order to understand the basic ideas that will help address the statement of inquiry. Thank you so much.